There is a place where light dissolves into liquid and is reborn as vibrant color. A territory where every square inch pulsates with hues that defy human imagination, where the deep blue of the abyss meets explosions of incandescent orange, electric pink, and emerald green that seem painted by divine hands. This is the submerged kingdom that few eyes have ever witnessed in its absolute fullness, a parallel universe that exists a few meters below the surface of the tropical oceans, hidden from humanity for millennia of mystery and inaccessibility. Here, in the crystalline waters that bathe the Coral Triangle, between the coasts of Indonesia, the Philippines, Malaysia, Papua New Guinea, the Solomon Islands, and East Timor, lies the greatest marine biodiversity on planet Earth, a sanctuary of approximately 6 million square kilometers, inhabited by more than 600 species of reef-building corals, and more than 2,000 species of reef fish. Scientists call it the Amazon of the oceans, but no terrestrial name can truly capture the chromatic magnitude of this underwater paradise that we will unveil together today. Prepare your senses for a journey that transcends the screen and penetrates directly into your soul, because in the following pages of this documentary, you will be transported to depths where reality surpasses any special effect ever created by human technology. We will dive into waters that maintain temperatures between 26 and 30 degrees Celsius throughout the year, the perfect thermal condition to sustain the most spectacular color show that nature has ever conceived in 4.5 billion years of planetary evolution. Each creature you will find in these waters carries within its body millions of years of aesthetic refinement. Each scale reflects survival strategies encoded in pigments and patterns that communicate danger, seduction, camouflage, or pure vital exuberance. This is not just a documentary about colorful fish. It is an expedition to the pulsating heart of cosmic creativity, to the living laboratory where life experiments with infinite combinations of beauty without ever repeating itself. Welcome to the Kingdom of 1,000 Colors. In the shallow waters surrounding Raja Ampat Island, located in the far northwest of Indonesia's West Papua, at approximately 0 degrees south latitude and 130 degrees east longitude, rises silently the largest living cathedral on the planet. Stony corals, scientifically known as scleractinians, build monumental structures here that rival in architectural complexity any masterpiece of human engineering, slowly depositing calcium carbonate extracted from seawater at a growth rate that varies between 5 and 25 millimeters per year, depending on the species and environmental conditions. The giant brain coral, with its labyrinthine convolutions in shades of golden brown and moss green, can live for over 900 years, silently witnessing the passage of entire human dynasties while continuing its patient underwater construction work. Beside it, the staghorn coral extends its delicate branches in shades of lavender and sky blue, creating three-dimensional underwater forests that shelter thousands of dependent species. With each tropical sunrise, when the first rays penetrate the surface at angles of approximately 45 degrees, these limestone structures transform into living prisms that decompose white light across the entire visible spectrum. However, the true chromatic magic of corals does not reside in their mineral skeletons, but in the microscopic beings that inhabit their tissues in one of nature's oldest and most sophisticated symbioses. Zooxanthellae, single-celled algae of the genus Symbiodinium, live in the millions within each coral polyp, performing photosynthesis and transferring up to 90% of the nutrients produced to their host in exchange for shelter and access to filtered sunlight. It is these tiny plant partners that give corals their most vibrant hues: the sunny yellows, the fluorescent greens, the incandescent oranges that seem to radiate their own light in tropical waters. At depths between 15 and 40 meters, where the red light of the spectrum has already been absorbed by the water column, corals have developed extraordinary fluorescent pigments that capture blue and ultraviolet wavelengths and re-emit them as bright green, orange, and red, creating a visual phenomenon that scientists have only begun to fully understand in the last 2 decades. This natural fluorescence transforms the night reefs into alien landscapes of indescribable beauty, a spectacle that remained invisible to the human eye until the development of special filters for underwater photography. Among the submerged roots of the Lembe mangroves, a volcanic strait located at the northernmost tip of Sulawesi Island, Indonesia, at approximately 1.5 degrees north latitude, lives a creature that seems to have escaped from a fever dream of a surrealist artist. The mandarin fish, whose scientific name, Syncheiropus splendidus, derives from the ancient Greek meaning feet and hands joined, and the Latin for bright or resplendent, boasts a mantle of such intense colors and intricate patterns that scientists initially doubted the first reports from divers who encountered it. Its body, only 6 to 8 centimeters long, displays an impossible electric blue background, not produced by conventional pigments, but by specialized cells called cyanophores that contain true blue pigment, a characteristic shared by only one other vertebrate species on the planet. Against this celestial blue, ripples and spots of vibrant orange, emerald green, and golden yellow ripple, creating patterns that are never repeated between individuals, making each mandarin fish a unique and unrepeatable work of art in the history of the universe. The mandarin fish's mating ritual occurs exclusively during the first 20 minutes after sunset, a spectacle that has been repeated at the same geographic coordinates for millions of years. The males, slightly larger and more colorful than the females, emerge from their hiding places among debris of dead coral and begin an elaborate display dance, raising their ornate dorsal fins like chromatic war flags. The chosen female approaches cautiously, assessing the suitor's genetic quality by the intensity of his colors. The more vibrant the blue, the healthier the male, and the better the genes he will pass on to his offspring. When the decision is made, the pair ascends together in a spiral to approximately 1 meter above the substrate, simultaneously releasing eggs and sperm in an ephemeral cloud of potential life before disappearing again into the protective shadows of twilight. This moment, which lasts less than 5 seconds, represents the climax of weeks of competition between males and can determine the continuity of genetic lineages that date back to geological eras prior to the emergence of the first hominids. In the waters surrounding Komodo National Park, an archipelago nestled between the islands of Sumbawa and Flores in Indonesia at approximately 8 degrees south latitude, powerful ocean currents carry nutrients from the abyssal depths to the sunlit surface, creating bursts of plankton that attract congregations of fish on scales defying numerical comprehension. Schools of yellow-striped barracuda, often numbering over 10,000 individuals, form living tornadoes of silver and gold that swirl in perfect synchrony, each fish maintaining a precise distance of exactly 1 body length from its nearest neighbors through a sensory system called the lateral line, which detects minute changes in water pressure. Viewed from within, this formation creates a 3-dimensional kaleidoscope, where sunlight fragments into thousands of golden reflections that pulse and ripple as if the ocean itself were breathing through metallic scales. Scientists have calculated that communication between members of the school occurs in less than 40 milliseconds, a speed that allows for coordinated evasive maneuvers against predators without any individual leader needing to issue commands. But it is the schools of Fusili that offer the most mesmerizing chromatic spectacle in these Indonesian waters. Aggregations of hundreds of thousands of fish that transform entire reef walls into living rivers of sky blue and canary yellow. Fusili of the genus Cesio swim incessantly in undulating formations that seem to obey invisible choreographies, feeding on zooplankton suspended in the water column while maintaining collective vigilance against approaching predators. When a threat is detected, be it a black-tip shark or a yellowfin tuna, the school executes evasive maneuvers that create waves of color propagating through the mass of fish, like electrical pulses through a giant nervous tissue. This emergent collective intelligence, where thousands of tiny brains function as neurons of a distributed mind, represents one of the most fascinating phenomena in behavioral biology and demonstrates that group consciousness can arise spontaneously when enough individuals follow simple rules of proximity and alignment. The visual result is a living painting in constant transformation, a natural abstract expressionism that no human artist has ever been able to replicate on canvas or in digital code. On the vertical walls of the Wakatobi Reefs, a coral archipelago located southeast of Sulawesi at approximately 5.5 degrees south latitude, live the undisputed aristocrats of tropical marine beauty. The adult emperor angelfish displays a pattern of alternating horizontal stripes of deep royal blue and bright solar yellow that extends across its laterally flattened body, reaching up to 40 centimeters in length in exceptional individuals. This adult coloration, however, represents a complete metamorphosis. Juveniles of the same species boast completely different patterns, with concentric circles of light blue, white, and dark blue that create mesmerizing optical illusions and confuse predators about the fish's actual size and direction of movement. The gradual transformation between juvenile and adult patterns takes approximately 4 years to complete, during which time the fish goes through dozens of intermediate stages, each more elaborate than the last, as if nature were patiently refining a masterpiece that it never considers finished. Butterfly fish, close relatives of angelfish but belonging to the Chaetodontidae family, have developed a radically different visual strategy to navigate the dangers of the tropical reef. The false-eye butterfly fish displays a large black circular spot surrounded by a conspicuous white ring positioned near the tail, perfectly mimicking a giant eye that confuses predators as to which end of the fish represents the head, and therefore the likely direction of escape. This illusion saves millions of lives daily on Indo-Pacific reefs, demonstrating how evolution transforms pigments into survival tools, as effective as claws or venoms. The masked butterfly fish adds an extra layer of visual sophistication with a vertical black stripe across its true eyes, camouflaging them against the yellow and white body pattern and completing the illusion that redirects predator attacks to the wrong end of the body. Each species of butterfly fish, and there are approximately 130 catalogued, has developed its own unique color solution to the same ecological challenges, creating an evolving gallery of graphic design that surpasses in creativity any human visual identity studio. In the black volcanic sands of the Lemba Strait, a marine corridor only 15 kilometers long that separates Lembe Island from the northernmost tip of Sulawesi, lives the undisputed champion of color manipulation in the animal kingdom. The mimic octopus, the Octopus mimicus, discovered by science only in 1998, possesses the ability to alter not only its color, but also its body texture and physical posture to mimic more than 15 different species of marine animals, including venomous lionfish, flatfish, deadly sea snakes, and even undulating anemones. This transformation occurs in less than 300 milliseconds thanks to specialized cells called chromatophores, elastic sacs containing pigments that can be expanded or contracted by surrounding muscles controlled directly by the animal's central nervous system. Beneath each chromatophore lie layers of iridophores and leucophores that manipulate light reflection to create metallic, iridescent, and pure white effects, completing a chromatic palette that rivals any modern digital painting canvas. The flamboyant cuttlefish, Metasepia pfefferi, represents perhaps the most spectacular expression of cephalopod chromatic technology, an animal measuring only 6 to 8 centimeters that inhabits the same sandy bottoms of Lembe and northern Australia. Unlike other cuttlefish that flee by swimming when threatened, the flamboyant cuttlefish walks elegantly across the substrate using modified arms as legs, displaying mesmerizing pulses of yellow, purple, white, and brown that ripple across its body like waves of liquid neon. This display is not gratuitous. Studies indicate that the flamboyant cuttlefish possesses toxins in its muscles comparable in lethality to those of the blue-ringed octopus, and its vibrant colors serve as a clear warning to any potential predator about the dangerous consequences of a bite. Scientists have documented that this animal's chromatic patterns can change completely more than 50 times per minute during social interactions or encounters with threats, creating sequences of visual communication so complex that they have not yet been fully decoded by human science. Each individual appears to possess a personal repertoire of patterns, suggesting levels of individuality and expression that challenge our traditional conceptions of invertebrate consciousness. In the shallow, sheltered waters of Australia's Great Barrier Reef, stretching over 2,300 kilometers along the Queensland coast between latitudes 10 and 24 degrees south, flourish the most spectacular anemone gardens in the southern hemisphere. These creatures, technically classified as cnidarians and close relatives of jellyfish and corals, have developed stinging tentacles laden with nematocysts, microscopic capsules that release paralyzing toxins in less than 3 milliseconds when stimulated by physical or chemical contact. However, to the eyes observing them through diving masks, the anemones represent bursts of vibrant color in shades of electric magenta, fluorescent lime green, tangerine orange, and royal purple that seem to vibrate with their own energy under the tropical sunlight. The magnificent anemone can reach diameters of over a meter, creating undulating carpets of tentacles that transform dead rocks and corals into underwater gardens of carnivorous flowers that capture unsuspecting prey with ruthless efficiency. Within these poisonous gardens, one of nature's most iconic partnerships has developed over millions of years of careful co-evolution. Clownfish, belonging to the genus Amphiprion and immortalized in popular culture by animated films, have developed immunity to the deadly stings of their host anemones through a special mucus layer that covers their scales and deceives the chemical sensors of the nematocysts. In exchange for absolute protection from predators, clownfish aggressively defend their anemone against butterfly fish that would feed on its tentacles, in addition to providing nutrients through their feces and improving the circulation of oxygenated water between the tentacles through their constant movements. There are 28 catalogued species of clownfish, each exhibiting unique variations of orange, yellow, red, black, and white, from the solid orange tomato clownfish to the saddle clownfish with its distinctive white saddle-shaped marking. This symbiosis represents one of the most visually spectacular examples of mutualism in the animal kingdom. A chromatic alliance where beauty and evolutionary function merge in perfect harmony. Below the euphotic zone, where sunlight no longer penetrates with sufficient intensity to sustain conventional photosynthesis, lies a twilight realm that scientists call the mesophotic zone, generally situated between 30 and 150 meters deep. On the vertical walls that descend abruptly from the edges of the Palo Atoll, a Micronesian archipelago located approximately 7 degrees north latitude in the western Pacific, this world of bluish twilight harbors communities of organisms that have developed radically different chromatic strategies from their shallow water relatives. Black corals, belonging to the order Antipatheria, build forests of proteinaceous skeletons in deep ebony tones that contrast dramatically with the white or golden polyps that coat their branches, creating Gothic landscapes of austere beauty that can live for more than 4,000 years. Deep-sea damselfish have developed predominantly blue and violet colorations, precisely the wavelengths that best penetrate the water column, creating spectral silhouettes that seem to float between dimensions. At this boundary between light and darkness, bioluminescence emerges as the dominant chromatic technology, allowing organisms to create their own light in a world where the sun represents only a distant memory, refracted through tens of meters of seawater. Lanternfish, tiny pelagic inhabitants that visit the edges of mesophotic reefs at night, possess photophoric organs beneath their eyes that emit blue-green light through chemical reactions between luciferin and luciferase, the same molecules that make fireflies glow on tropical terrestrial nights. This light serves for communication between individuals, attraction of planktonic prey, and confusion of predators through flashing patterns that can be voluntarily modulated by the fish's nervous system. In even greater depths, beyond the limits of recreational diving, bioluminescent jellyfish create living constellations that rival the most starry night sky, demonstrating that evolution finds pathways to chromatic beauty even where sunlight has never reached in the entire history of planet Earth. The stunning magnitude of this chromatic biodiversity that we document exists today in precarious equilibrium, threatened by forces operating on scales ranging from the local to the planetary. Coral bleaching, a phenomenon caused by rising ocean temperatures that forces the expulsion of symbiotic zooxanthellae, has already caused the loss of approximately 30% of the corals in the Australian Great Barrier Reef in the 2016 event alone, transforming multicolored landscapes into ghostly white cemeteries. Ocean acidification, a direct consequence of the absorption of approximately 1/3 of the carbon dioxide emitted by the burning of fossil fuels, slowly corrodes the calcareous skeletons that support the entire reef ecosystem, threatening to dissolve in decades structures that took millennia to form. Plastic pollution, destructive overfishing, sedimentation caused by coastal deforestation. Each of these forces removes threads from the chromatic fabric we celebrate today, irreversibly impoverishing the color palette available to future generations of divers, scientists, and simply human beings who find meaning and inspiration in contemplating natural beauty. However, amidst the shadows of threats, points of light of hope shine with increasing intensity across the world's oceans. Protected marine areas, such as Tubataha National Park in the Philippines, the Palau Sanctuary, and the Misul Marine Reserve in Raja Ampat, demonstrate that, when protected from destructive exploitation, coral reefs can recover with surprising speed, repopulating with colorful fish and regenerating damaged corals. Traditional coastal communities rediscover ancestral practices of sustainable management, while scientists develop coral restoration techniques that accelerate natural recovery processes by decades. Responsible dive tourism transforms living reefs into more valuable economic resources than any amount of dead fish, encouraging governments and communities to protect what they once destroyed. Hope does not reside in magical technologies or simple solutions, but in humanity's repeatedly demonstrated capacity to change course when confronted with the magnificence of what it risks losing. And no magnificence surpasses that which you witness today in this kingdom of 1,000 colors. You have just journeyed through a universe that exists just a few meters below the surface of tropical oceans. A realm where every cubic centimeter of water contains stories of evolution, survival, and beauty written in living pigments over hundreds of millions of years. This documentary represents only a glimpse, a half-open window to infinite wonders that await curious eyes willing to dive beyond the surface of the everyday. If these images touched you deeply, if for a few minutes you felt the primal awe that our ancestors must have experienced when contemplating the ocean for the first time, then I make a sincere request. Like this video, subscribe to our channel, and activate the notification bell to continue this journey with us. Each subscription strengthens our mission to document and share the wonders of the natural world. Each view allows us to reach more people and awaken more awareness of the urgency of protecting these treasures. Share this video with someone you love, because beauty, like love, multiplies when shared. Until the next expedition, Guardians of the Blue.